here, we're going to evaluate an integral using integration by parts. But because we have some trig in here, we end up using some trig substitution to help us evaluate this. So thinking about this integral, we have 0 to pi over 9 of x times tangent squared of 3x integrated with respect to x. So thinking about Liate, I'm going to allow my algebraic term x to equal u. And then v prime will equal tangent squared of 3x. So the derivative of u prime, would be 1, or dx. And v, that's pretty hard for me to integrate. So I'm going to say that v is just the integral of tangent squared 3x dx. Now, keep in mind, we know some trig identities. And our Pythagorean trig identity, tangent squared x plus 1 equals secant squared x, or rather tangent squared x equals secant squared x minus 1. So I can rewrite this integral, and this would be the integral of secant squared 3x minus 1. And this I know how to integrate. Secant squared 3x, the integral of secant squared is tangent, and because we have this 3 in there, we will divide by the 3. So this will become tangent of 3x over 3. And then the integral of 1, that's just going to become x. So here I have a nice value for my v. So let's think about what this will be equal to, applying our integration by parts. So this is going to be u times v, which is x times v, 1/3 tangent of 3x minus x. And of course, because this is a definite integral, we're going to need to go from pi over 9 to 0, minus the integral from 0 to pi over 9 of v times u prime. So v times u prime. And u prime is just going to be 1. We don't need to write that there. So we've got the integral of, I'm going to write this as 1/3 tangent of 3x minus x dx. Right, so this is where we are after applying my integration by parts. And I'm not going to worry about evaluating this until I get to the end, unless I end up changing bounds. But I don't need to do that. So I have x over 3, tangent of 3x, I'm just distributing, minus x squared, pi over 9 to 0, minus, I have 1/3 the integral from 0 to pi over 9 of tangent 3x dx, and minus a negative, that would be plus the integral from 0 to pi over 9 of x dx. So continuing along, I'm just going to bring this first piece down. I have x over 3 tangent of 3x minus x squared. Again, all of that's going to be evaluated between pi over 9 and 0, minus 1/3. So now I need to integrate this piece right here that I've just underlined in green. And the integral of tangent, that's something we know from our table. So that's going to be 1/3 the natural log of the secant of 3x. We use absolute value bars on our natural log because we know that that argument has to be positive. And then we have this other piece right here. This would be plus x squared over 2, using the power rule to integrate. So that is also going to be integrated between pi over 9 and 0. So let me clean this up a little bit, and then we'll start plugging in values. I have x over 3 tangent of 3x minus x squared. That should be a minus 1/9 the natural log of the secant of 3x plus x squared over 2. And so my limits or my bounds of integration here, I have pi over 9 and 0. So the rest of this problem is really just busy work. I'm going to plug pi over 9 into all of these terms, and then I'll plug 0 into all of these terms. So I have pi over 9 over 3. That's going to be pi over 27. I have the tangent of 3 times pi over 9. So that's the tangent of pi over 3 when I plug that in there. Minus pi over 9 squared. That's going to be pi squared over 81. Minus 1/9 times the natural log of the secant of 3 times pi over 9. 3 times pi over 9, that's going to be pi over 3. Plus pi over 9 squared divided by 2. Pi over 9 squared is going to be pi squared over 81. And then you take that 81 and multiply it by 2, because the divide by 2, you're going to get 162. So this becomes pi squared over 162. So that's my first piece. And then I'll have minus 0 over 3. So I'll have 0 of that tangent of 3 times 0. Well, 0 of anything, that first term will be 0. Minus 0 squared minus 1/9 times the natural log of whatever the secant of 3 times 0 is. So I'm just going to call that secant of 0 there. Plus 0 squared over 2, which would again be 0. And I notice here I said 1/9, but I wrote 1/2, so I'm going to correct that right there. That should be a 1/9. So now we look at simplifying this. So pi over 27, tangent of pi over 3 is root 3, minus pi squared over 81, minus 1/9 natural log secant of pi over 3 is 2. So at pi over 3, my cosine value is 1/2. Secant's reciprocal, that would be 2. Plus pi squared over 162. And then, as we said, we've got minus 0, minus 0, minus a negative. That's going to be plus 1/9, the natural log. Secant of 0 is 1. And then 0 squared over 2 is 0. And then noticing secant of 0 being 1, natural log of 1 is 0. So we have a lot of terms that zero out. So there are 2 terms left that I can add together. I can add these pi squares together, and negative 1 over 81 plus positive 1 over 162 gives us negative 1 over 162. So my final exact answer here is pi root 3 over 27 minus pi squared over 162, and then we would have minus 1/9 the natural log of 2. So we have completed an integration by parts example. It was a definite integral where we had to evaluate at the end, so there was no plus c. And we also needed to use a trig substitution. We used the trig Pythagorean identity for tangent. As always, email me if you have any questions.